There are many, many, many programming languages. I've put just 5 on the screen, but there's hundreds um, of them out there. And why is C so special? So you can just look at the programs that I've put out here, and you can tell that C is not the most laconic of languages. If you want to print hello world, Python lets you do it much more easily. And you can see the clear difference in the complexity of the code that you have to write for what I'm calling a compiled language like C and C++, and an interpreted language like Python or JavaScript. Now, why is this? To understand this, you have to know what a compiler actually does. What a compiler does is it takes your code and it translates it into machine language for the computer to understand. What an interpreter does is it itself is a piece of code that takes command of the machine's behavior and acts as a translator between your intent and the machine's operation. So when you write a program in Python, the Python interpreter is a pre-existing piece of code that is actually written in C. Python is written in C. And when you say print hello world, that essentially just becomes an input. Your program becomes an input to that existing program, and it says, well, if I get this particular input, print hello world, I know what to do with it. So in a language like C, which is compiled, you start from scratch. You can have a computer that is running no program. You write your C program, you run the compiler on it. Now you have a piece of code that has been converted to a machine level language, and that program can now run independently on your machine. On the other hand, your Python program can only act as an input into a pre-existing program, which is the Python interpreter. It cannot run by itself. It only ever runs as an input inside a larger program. It's like Inception. You had dreams within dreams, now you have programs within programs. That's what happens with interpreted languages. That is why they tend to be more laconic in their expression, but they give you less control over what you can do with the hardware. So the typical programming cycle for compiled languages is a little bit more elaborate than for interpreted languages, if that's what you're familiar with. Most of the times, what happens is that we write our code and then we compile it. And when you compile, it can compile either with errors, which means that the compilation did not succeed, or it can compile successfully. When you first start programming in C, you will face many problems. Your compilers will always be giving you cryptic error messages saying this is wrong, that is wrong. So when that happens, you have to come back and edit your code. And then you compile again. And you keep trying until the compilation succeeds. When it succeeds, then you run your code. And by running the code, what that means is you take the machine level instructions that were produced by the compiler, and you ask your computer to run it. And when that works, you will get some output. If the output is what you expected, that means your program worked. If your output is unexpected, it means there's a bug in your logic. So there's a distinction between syntax errors that are problems with getting your code to compile and logic errors where the code compiles but your output is different from what you expected, in which case you have to go back and rewrite your code because there's something in the logic that you haven't really thought through. So this is the typical cycle of programming. And in the first couple of weeks, it will mostly be just compile, compile, compile. Please, will you compile? But then as you become more proficient, your syntax error rate will drop and you will get better at just automatically getting the right syntax into your program. And then you'll be free to think about the logic of your code, which is actually much more important.